A surprise solar flare has burst from an area of dense magnetism on the Sun's surface, causing a temporary radio blackout in some parts of Australia and almost all of New Zealand. The geomagnetic storm from the flare apparently disrupted our planet's radio signals and satellite communications, leading to the reported blackouts, which were not the first of their kind to happen this year. The M5 class medium-strength solar flare was recorded by NASA's Solar Dynamics Observatory as it erupted from the sunspot AR3141 at 7:11 p.m. ET on Sunday, November 6th. The flare created a rush of radiation that ionized the Earth's atmosphere, according to spaceweather.com. Sunspots are dark regions on the Earth's surface where powerful magnetic fields created by the flow of electrical charges knot into kinks before suddenly snapping. The resulting release of energy launches bursts of radiation called solar flares and explosive jets of solar material called coronal mass ejections, CMEs. A CME did accompany this flare, but it was not aimed at Earth. The solar flare erupted unexpectedly and took scientists by surprise. Our apologies, there was no alert for this event. The flare was impulsive. The solar activity tracking website Space Weather Live posted on Twitter. The National Oceanic and Atmospheric Administration (NOAA) classifies solar flares in 5 categories: A, B, C, M, and X, based on the intensity of the X-rays that they release, with each level having 10 times the intensity of the last. Once they reach Earth, X-rays and ultraviolet radiation produced by the solar flares ionize atoms in our upper atmosphere, making it impossible to bounce high-frequency radio waves from them and thus creating a radio blackout. Radio blackouts occur over the areas lit by the sun during the time of the flare, and they are classified from R1 to R5 according to severity. This most recent flare caused a moderate R2 blackout. Solar activity, which astronomers have tracked since 1775, rises and falls according to a roughly 11-year cycle. Solar activity has been especially high recently, with sunspot numbers nearly twice those of NOAA predictions. The increased activity has sent waves of high-energy plasma and X-ray bursts slamming into Earth's magnetic fields, downing Starlink satellites, triggering radio blackouts, and causing auroras as far south as Pennsylvania, Iowa, and Oregon in the United States. Many more flares are likely to lash Earth in the coming years. The Sun's activity is projected to steadily climb, reaching an overall maximum in 2025 before decreasing again. The blackouts in the Oceania countries are hence likely to be followed by additional solar explosions in other parts of the world in the coming months and years under the current solar cycle 625. This ramp up in activity means that on the night of a solar storm, the northern lights will be visible much further south than usual. This is because Earth's magnetic field gets compressed slightly by the waves of highly energetic particles, which ripple down magnetic field lines and agitate molecules in the atmosphere. This then releases energy in the form of light to create colorful shifting curtains in the night sky. Interesting, isn't it? Do tell us your thoughts about it in the comment section below. Thanks for watching.